Differentiate y equals x squared times ln of x. This is the product, so we will use the product rule. Y prime equals, we differentiate the first factor, the derivative of x squared is 2x, and then multiply the second factor, plus we keep the first factor x squared and multiply the derivative of ln of x, which is 1 over x, and then we simplify. 2x ln of x plus x. This is y prime. B, y equals the square root of 1 plus ln of 1 minus x. This is the composite of function with the outer function being the radical. The innermost function is 1 minus x. Using the chain rule, y prime equals the derivative of the square root is 1 over 2, the square root of the same argument inside. So we would rewrite 1 plus ln of 1 minus x. And then we multiply the derivative of this inner function, which is derivative of 1 is 0 plus the derivative of ln of something is 1 over the inner function, which is 1 minus x. And don't forget to multiply the derivative of the inner function right away, which in this case, negative 1. We still need to simplify this. This is negative 1 in the numerator, and then 2 the square root of 1 plus ln of 1 minus x. And then we still have a factor of 1 minus x in the denominator. To make it look nicer, we would write this as 1 over 2 x minus 1, the square root of 1 plus ln of 1 minus x, where we switch 1 minus x to x minus 1 and factor out the negative 1. And so the negative and the negative canceled out. Usually, we write the radical at the end. Differentiate y equals ln of x plus 1 over the square root of x minus 1. There are two ways to do this. We will do it the hard way first. This is the composite of function with the outer function being ln and the inner function is the quotient, and inside the quotient there is a radical of something, so we will use the chain rule again. The outer function is ln, and so y prime is 1 over. The inside function of ln is x plus 1 over the square root of x minus 2. And then we would multiply the derivative of this inner function, which is a quotient. So we will square the denominator, the square root of x minus 2 squared. For the numerator in the quotient rule, we would take the derivative of the numerator times the denominator minus, we keep the numerator times the derivative of the denominator, and that is the derivative of x plus 1 is 1 plus 0 or 1 times the denominator minus, this time we keep the numerator and multiply the derivative of the denominator, which is 1 over 2 root x minus 2 times the derivative of x minus 2 is 1. We still need to simplify this. For the first factor, 1 over a fraction is the reciprocal, and so this is the square root of x minus 2 over x plus 1. And then the square root of x minus 2 squared is x minus 2. In the numerator, we have the square root of x minus 2 minus x plus 1 over 2 the square root of x minus 2. And so for the second factor, we will still need to simplify it by adding or combining the two terms. The common denominator in the numerator is 2 the square root of x minus 2. And so we would take the square root of x minus 2 times 2, the square root of x minus 2 over 2, the square root of x minus 2. Notice that this will give us the square root of x minus 2 back. Minus x plus 1 over 2, the square root of x minus 2. We do that because we want to combine the two terms. And so this is the square root of x minus 2 over x plus 1 times 2 times root x minus 2 times root x minus 2 is 2x minus 2 minus x plus 1. We can subtract the numerator because they have the same denominator, 2 root x minus 2. And then divided by x minus 2 is the same as multiplying the reciprocal of x minus 2, which is 1 over x minus 2. And notice that we can cancel out this radical. In the numerator, we end up with 2x minus 4 minus x minus 1. And in the denominator, we have 2 times x plus 1 times x minus 2. And clean this up a little bit further, we have the answer is x minus 5 over 2 times x plus 1 times x minus 2. And this is the derivative y prime. Alternatively, we will use the law of logarithm to differentiate the original expression y equals ln of x plus 1 over the square root of x minus 2. Keep in mind that the argument of log needs to be positive and x minus 2 needs to be positive as well, because not only it is in the denominator, but it is also inside the square root. And so using the law of logarithm, we can write this as ln of the numerator minus ln of the denominator. And then we can expand this further. This is still y. ln of x plus 1 minus ln of x minus 2 to the 1/2 power. And then we move the 1/2 power to the front of ln. And again, this is still y, not y prime. ln of x minus 2. And so that is as far as we can expand. Y prime is now, remember that the derivative of ln is 1 over, and then we still need to multiply the derivative of the inside of ln, but the derivative of x plus 1 is 1. Minus 1/2, the derivative of ln of x minus 2 is 1 over x minus 2. And so the answer is 1 over x plus 1 minus 1 over 2x minus 2. Now, this is a simpler answer, although we still need to restrict the domain. The domain of this function is whenever the argument of ln, which is x plus 1, over square root of x minus 2 greater than 0. Again, keep in mind that we still need to have x minus 2 strictly greater than 0. It cannot be 0 because it is inside the radical. And so x has to be greater than 2 for 1. And then we will still need to solve this inequality. The 0 in the numerator is negative 1, and the 0 in the denominator is 2. And then we test the sign. We will see that this is only positive for x greater than 2. And so this solution is the derivative of the original equation, assuming that x is greater than 2.